Briefly, an exponential function has the form y equals f of x equals b to the x for some positive number b. And it has the rule that an exponential function can be defined as a function whose graph has this characteristic. Okay, the y value doubles when the x value changes by a fixed amount. And we're going to call that fixed amount the doubling displacement and represent it graphically by an arrow. So, if we draw an x-axis, and the y-axis doesn't have to be drawn yet. Y-axis can be, you can set up the x-axis and draw the y-axis later. So we construct the graph by simply drawing an x-axis and then by putting an arrow representing the doubling displacement head to tail, head to tail, head to tail across just under the x-axis. So that every time we move from the x value at the head of an arrow to the x value at the head of the next arrow, the y value is going to have to double. And then we simply make it happen. Now, in constructing this graph, I chose this point. I set a compass at this width and then doubled that width to get this point here, so that the y value between here and here doubles. Here's the doubling displacement. When x changes by the amount equal to the doubling displacement, the y value is doubled. Then I can take another compass and set it here and do this and this. Double the y value once more, so after the next doubling displacement, the y value will have again doubled. Then it again doubles to get the y value here. To move backwards, in other words, we started with this point, and this point weren't yet marked. Well, the y value at this point has to double to get here, so that the y value at this point is just cut in half to get this. We can do that with a compass and straight edge if we have a small enough one and have fine enough instrumentation. We can just construct the bisector of the segment between this point and this point on the x-axis, this point on the graph, this point on the x-axis, and we then set this point at the y value at the midpoint there. And then we just cut this distance in half. We can do this again in principle with a compass and straight edge and set a point here. So now we can simply sketch the graph and we have it. A couple of things. If we know the doubling displacement, we can find b. If we know b, we can find the doubling displacement. I'm not going to tell you how that's done right now, but it's a very simple relationship. And now, after having constructed the graph, and we could have done it before, it doesn't really matter where the y-axis goes. We can set the y-axis down any place. We still don't have a scale on the x or the y. We just know that this is the doubling displacement. And now we put our y-axis here. Now the graph can represent any exponential function y equals f of x equals b to the x, or even y equals f of x equals a times b to the x, as long as a is positive, because all the y values here are positive, as long as b is greater than 1. Okay? So any graph at all, any exponential function at all, with b greater than 1, even if you have a positive number in front of it, can be represented by this graph.